everybody. My name is Umair Surani. I work at Fujitsu General America. I wish I was a former aerospace engineer. I just got a degree. And then I got a job into the HVAC industry back in 2011 as a certification engineer at AHRI, where I dealt with the VRF certification program and standard development, and then switched to Fujitsu about 4.5 years ago, where I currently serve as a VRF sales engineer for your market. So, great overview, Larry. And now I'm going to be talking about how to integrate air source heat pump technology into large-scale commercial projects. So any large-scale commercial project, I like to break it down into 3 different phases. The first is a pre-installation phase. That's before any equipment is going to be going inside that building when it comes to air source heat pumps. The first thing I like to see happen in that pre-installation phase is that building owner asking, why heat pump? What benefits would I get with heat pump technology that I may not with something else? Okay, is it zoning that I'm looking for? Is it added comfort? Is it more efficiency? Is it lower operation cost? All of the above, right? Once you have that question answered, then we get into a heat load calculation. Okay. Also, determine what kind of electrical capacity you already have if it's an existing building, or you'll need if it's a new building, depending on the type of system you want to go with. And then also, depending on the owner's needs, obviously they're going to have a budget that they want to work around, right? But also an ROI calculation typically comes into play when we're talking about integrating air source heat pumps into large-scale projects. And then based on that, you select your system and configure it, right? And then in this area, we have the luxury of having a pretty lucrative utility incentive program. Some other markets around the US have that as well. So if the owner is interested in, taking advantage of that, then those programs typically require some sort of an energy study when it comes to air source heat pumps, particularly VRF, because they tend to be a little bit more involved. Okay, and all of these functions here are typically performed by, an engineering firm or an architect and engineering firm or something of the sort. And then once you have everything down on paper, before you can go and start installing the equipment, if you wanted to get that utility rebate, you're probably going to have to do a pre-inspection before installation begins. And that's done by the utility company. Then lastly, selecting a mechanical contractor to do that install. So again, on the right here, you see a bunch of people, right? This is forming a team for the pre-installation phase, okay? Also, these steps are by no means in any particular order, okay? Selecting a contractor may begin or may happen at the very beginning of this phase, right? If it's a private project, it's an existing building, contractor has a pre-existing relationship with the building owner, he may be involved throughout the process from the very beginning, okay? But these steps are happening in some order in this pre-installation phase. Next, we move into the installation phase, okay? This isn't just about installing the equipment. There's a lot more that goes into this phase. Some of these things are training, okay? The contractor that's going to be installing, depending on the brand that they're installing, needs to go get trained on that product, right? Project walkthroughs, okay, something got put down on paper. Hey, is that exactly going to go in the way it was designed on paper? 9 times out of 10, probably not. Okay, so you do project walkthroughs. You walk the building to see if there are any design changes that need to be made before you start sourcing the equipment, right? Because you don't want to get wrong equipment and then realize, oh crap, right? So then you source the equipment, you begin the installation of the system, okay? Larry described how that system looks, outdoor units, indoor units, controls, refrigerant piping, communication wiring, ductwork, if any, if you were using ducted units. And then the last step in the installation phase is startup. Okay. All of these functions are performed typically between the mechanical contractor and the equipment manufacturer or the distributor supplying that equipment that typically has some technical service advisors that are supporting the contractor along the way. Okay. And then the third phase is post-installation. Okay, here you do your local code inspection, okay, by a local officer. Right? And then for the equipment side of things, for the air source heat pumps, the manufacturer typically does commissioning of the system, which then approves an extended warranty on the system, and then you get into the service and maintenance phase. So in those 3 slides I just showed you, I just named a bunch of people that you saw on the right side of the screen. That's basically your team for a large-scale air source heat pump project. Okay? The more cohesive this team is, the more chances of this project being smooth and very successful from the start. Okay. All right, so all this is great. Let's talk about an example. So there just so happens to be a 4-story, 71,000 square feet building, 0.5 miles away from here in Terrytown, where the existing system is being upgraded to VRF heat pump plus high efficiency ERVs. What does the old system look like? Well, it's a dinosaur fossil. Okay? If you guys have ever seen that movie, Jurassic Park, which I know most everybody has, there's that one scene where the people are sitting in a car and their car, the dashboard is vibrating because there's a T-Rex breathing in the neighborhood, right? When this system comes on, the people on the 4th floor feel the exact same way, right? So what this system is 4 hot deck, cold deck, multi-zone RTUs, rooftop units that were installed 47 years ago when this building was constructed. And lately, over the last 2 years, the owner has been spending somewhere around 49 grand per year in maintenance costs. So it's time for a change. All right, so what does this project team look like? On the left, you see Juan Perez from Fujitsu Tech Support, so manufacturer. Right next to it is Glenn Grossman from Blendair Mechanical, the contractor, okay? In this case, Blendair had an existing relationship with the end user, with the customer, so he was selected from the very beginning and has been involved throughout all the phases that I discussed earlier. To his right is the distributor, Johnstone Supply, and that's Mike Teixeira, okay? And then that really happy guy to the right, okay, I don't know who that is, but he's also from the manufacturer. There are more people that were involved in this team, and then like any successful team, there are people working behind the scenes to make sure that we're successful, okay, to make sure our jobs are made easier. All right, so what did the pre-installation phase look like on this project? Okay, heat load calculation performed by an independent consulting engineering firm in RDH Building Sciences. Electrical capacity, determining that system controls and configuration, selection, and all that good stuff was done between the contractor, the engineer, and the sales specialist at the distributor. This owner was interested in an ROI calculation. He wanted to see what kind of return he's going to be getting on this investment because we're talking about a pretty large project, right? Also, this owner was interested in taking advantage of the Con Edison commercial incentive program. That also needed an energy analysis, okay? So that analysis was done by, again, RDH, the independent consulting firm. And then the engineer and the contractor helped out RDH, gave them all the data they need to be able to conduct that study. Okay, and then lastly, just recently, a pre-inspection was conducted by Con Edison, after which the installation was able to move forward. So installation phase, the training conducted by the distributor and the manufacturer. Project walkthroughs done by the distributor, manufacturer, and the contractor made sure the design is confirmed before equipment is sourced between, or changes hands between the distributor and the contractor. Okay, and then the contractor moves on to installing the equipment. And then lastly, startup. As the systems are installed, as you learned from Larry, these systems are modular, right? So as one system is installed, it gets started up, and the team that starts it up is, again, the manufacturer, distributor, and the contractor. So a team approach the entire way, okay? The installation for the entire building is still currently ongoing. Half the building is done. The other half will be done within the next several months. So, the post-installation phase hasn't begun yet. Okay, all right, so let's talk now about, the system and how it was configured, okay? So the building is divided essentially into 4 quadrants, okay? The existing or the old dinosaur fossils, each of them served one of these quadrants before, right? Removing those, we're basically essentially still going to configure the building in 4 quadrants, and we're going to place each VRF system on 1 floor per quadrant. So it's going to look something like this, okay? So here on floor number 1, in quadrant number 1, you have 4 ducted indoor units and 1 ceiling cassette, okay? That is being served by a bank of outdoor units that are on the roof. And they're piped through a chase down to those indoor units, okay? Same configuration is applied to the other 3 floors and the systems for those floors. Okay? And the same exact configuration is transposed into the other 3 quadrants. There's very little difference between the systems that are selected for each quadrant because each quadrant is almost identical to each other. If there are changes, they're very minimal. And again, those changes are confirmed in a walkthrough. Okay. All right, so this is how the system looks like, again, on paper. What does it look like to an end user who's in this building, right? So, well, actually, before that, let me go into the electrical. Sorry about that. Okay, so there is 460-volt power in this building, 3-phase. So the outdoor units that are selected are 460-volt, 3-phase power. It's a bank of 2 outdoor units in a system, so they need one 30-amp breaker and one 25-amp breaker. Okay, the indoor units in a system, all of them can be powered by one 15-amp breaker. So together, in one system, you need a 70-amp breaker size, right? Times that by 16. That's roughly around 1,100 amps. That's the maximum amount of amperage you're going to need to be able to power the VRF system for that entire building. That, however, is not the amp that these systems will be drawing when operating. This is just the maximum, the breaker size. Okay? The operation amps are significantly lower than that. All right, so again, what does this look like to the end user? Well, the end user that was used to seeing a diffuser before is still seeing a diffuser now with a ducted indoor unit behind it. Okay? But those corner offices that saw a diffuser before but had no individual control are now seeing a ceiling cassette on the ceiling with a controller or a thermostat or a remote, whatever you want to call it, on their wall. They now have individual control. The building administrator is seeing a zonal view of the entire building. He's also seeing how the ultra-high efficiency ERV that's selected for that building is operating, and also how the VRF system for that building is operating, what its guts are doing at any given point in time, right? And then lastly, the roof looks something like this today when half the building is done. The old units will be removed probably in the next few months, at least for half the building. So when this project is complete sometime later this year or early next year, all you're going to see is a very beautiful array of VRF condensers all over that roof. Okay. All right, so why did this owner decide to choose VRF heat pumps, but in this case VRF heat recovery systems, for this project? Well, a big one was added comfort. Okay? Right now, or before the VRF was installed, there were 48 zones in this building. With the super amazing zoning capability of VRF systems, we're able to take that to over 100. Okay, so now before, that occupant that could not control the temperature in their space can now do it. It's a big win, right? Also, variable speed technology equals really precise temperature control, kind of like the accelerator in your car. Okay, the amount of pressure you put in is how fast your car is going to go. Okay, also simultaneous cooling and heating. In the same system, one zone can give you heating while the other can give you cooling. And then also a really big one is it able to output sufficient heating capacity at low ambient temperatures? Okay, maintenance costs reduced significantly. Redundancy, one unit fails, the other 15 are still going to continue operating. Okay, ERVs were chosen because they're just, you need fresh air, and ultra-efficient ERVs combined with VRF is just a win-win scenario all the way around. Okay, what are we talking about when we say win-win? This is the current building energy consumption, okay, with the old systems, right? Red represents natural gas. If you replace it with like-to-like code minimum rooftop systems, it will go down to something like that. If you replace it with ERVs plus VRF, you reduce natural gas completely, replace it with cooling, but even then save 224,000 kilowatts in cooling and 38,000 therms in heating. Okay? And at the end of the day, that means your ROI is 3 years. Okay? Now, what about new construction projects? Because this was a retrofit. Well, if it's still in design phase, just incorporate it into the design. But if construction's already begun, then just treat it like a retrofit. The versatility of a VRF system gives you that flexibility. Okay? And that's it. If you guys have more questions, thank you.